All right, so we're going to do some formula finding. Now, we're going to start with potassium nitrite. Okay, so our first step is to identify the two parts of the formula. So the first is potassium, okay, and the second is nitrite, okay, which is NO2 minus 1. Now, the way I knew that was on my charge chart down here. We have nitrate, which I can't write on that because my screen is split, but it's at the very top, middle. It's the second one there, and it's listed as NO2 minus 1. Okay, so we got that. Now, this is an ionic compound because it starts with a metal. Okay, potassium is a metal. You know this because it is at the left side of the periodic table. Okay, it is number 19. Again, I can't write on it because my screen is split, but it's on the left side, number 19. That is also in the first column, so you know it is also plus 1. Okay, now, since we have plus 1 and minus 1, the whole goal of ionic compounds is to balance out the charge. So the overall charge, or the overall positive charge is plus 1 because there's only, we're gonna balance out the charge. So since we have plus 1 and minus 1, those two charges are going to balance each other out. So we only need 1 potassium and 1 nitrate. So our formula is going to be KNO2. Okay, start out with a nice easy one. Perfect. All right, now I'm going to erase this because I need some more room. All right, next one we're going to do is sodium sulfate. But let me finish erasing this first. All right, so sodium sulfate. Again, we start with identifying the two parts, okay? First is sodium, second is sulfite, okay? So we have sodium, which is Na, and we have sulfite, which we would look at our charge chart. Sulfite is right at the very bottom now, sulfite, SO3 minus 2. So we do SO3 minus 2. Okay, now again, we are starting with sodium, so that is a metal, and again, we know that that's a metal because it is on the left side of the periodic table. It is atomic number 11, so all the way to the left, number 11. That is a metal, so that means it is an ionic compound. So we are looking for the charges. So since sodium is in the first column, it's a plus 1 charge. Okay, now this time the charges don't balance out. We have a plus 1 and we have a minus 2. So what we need to do to balance those charges out is add another Na plus. I didn't plan that out very well. But so now we have 2 NAs. So now our overall positive charge is plus 2, and our overall negative charge is minus 2. So now we're balanced out. So now we write the formula. Since we have 2 NAs, we're just going to write it Na subscript 2. We only have 1 SO3, so we just write SO3. And that's that for that one. Okay, now I'm going to erase this again. All right, so next one, we are going to do lead 2 nitrate. So again, we identify the two parts, lead, which is Pb, and nitrate, which, according to our charge chart, is at the very top now, nitrate, so that's NO3 minus 1. Oh, that's a 3 minus 1. Okay, now lead is a metal, so that means this is again an ionic compound, so we have to find the charge of lead. Now lead is not in any of the 8 main groups, so what we have to do is we have to look at our Roman numeral. Okay, that Roman numeral tells us what the charge is. So since it's Roman numeral 2, that means lead is plus 2. Okay? Now, since lead is plus 2 and NO3 is minus 1, that means, again, our charges are unbalanced. So we're going to have to add another NO3 minus 1 to the mix. So now we have a minus 1 minus 2 charge, and we have a plus 2 charge. So now we're balanced. So now we write out the formula. Pb, and there's only one of them, so we just leave it at 1, and NO3. Now, since there are two NO3s, and NO3 is a polyatomic ion, we have to put NO3 in parentheses and put the 2 on the outside of the parentheses. The reason being is we can't just put the 2, we can't change this 3. That 3 is part of the polyatomic ion, so you can't change that. Anytime you have nitrate, it has to be NO3. So if we put this 2 next to the O, that changes it from nitrate. It's not nitrate anymore that way, okay? All right, now we are going to do a different kind of one. All right, we're going to do dinitrogen decafluoride. So again, first, we identify the two parts. So we have sulfur and fluoride. Okay, so sulfur is S. Fluoride is F. Okay, according to our periodic table. Now, since this has a prefix, what that means is this is a covalent compound. So since it's a covalent compound, all you have to do is look at the prefixes, and that's how many subscripts it has. Okay, sulfur has no prefix, so it's just going to have, it's not going to have a subscript. Fluoride, its prefix is di, which means 2, so its subscript is going to be 2. So our formula is just SF2. Okay. All right, now let's do silicon heptoxide. Oh, also, just so everybody knows, the prefixes are listed in your charge chart right there. All right, so silicon heptoxide. Okay, so again, identify our two parts. Silicon is Si, oxide is O, and again, we have a prefix, so that means it's a covalent compound, and we just look at what the prefixes are and turn that into our subscripts. Si, again, does not have a subscript, so it's just going to be Si with no subscript. O has a prefix of hept, which is, I can't get it all the way up, but let's see if I can get it down. Yes, I can. So at the very bottom there, hepta is 7, so that means O7, just like that. Okay? All right, I think that is all we're going to do for this.